figure out a little bit about our periodic table and some information we can tell us. Be sure to fill this out based off your memory, what you remember, how you would phrase it, and then at the end, once I kind of give you these rules based off the evidence that we've seen, kind of see if it does match what you already understand, because that's what you want to have going forward. All right, so we have this view of our periodic table, and these information, some of these you already know. So up at the top, we have the atomic number. Here's the symbol, atomic, kind of same symbol. Symbol. Ooh, that's terrible. Then we have the name. You don't need to memorize the names. You have the periodic table. But of course, the quicker you can recognize symbols as the names, that'll help a lot when we do things with naming. And then this is what's called the average atomic mass. We're not going to use this all quite right now. We're not going to go through why it's a decimal. It is not necessarily the number of neutrons and stuff that you might have learned in middle school or other classes. So right now, just be aware it's there, but we're not using it currently. As you see on this, atomic number, number of protons in the nucleus, number of electrons in a neutral atom. And remember, of course, it's the number up top. Now, again, I might be giving you some names or symbols, and you'll need to pull that out. But protons and electrons, and again, what we say is a neutral atom. In the activity that you did, we learned about things called ions. And this is where the protons and electrons, these are the symbols, are not equal, not the same. We'll get to that later, especially when we talk about the different things about compounds and other things. But for right now, that's how we get protons and electrons. Now in the activity titled, I think it's Living on the Edge, you got to talk about and look at energy levels and valence electrons. Valence electrons are the ones that react, so they're the most important. So I want you to be able to look at a periodic table and determine how many number of valence electrons there are, because that'll have great consequences going forward. I've devised a very simple rule in order to remember this, that it's the ones digit of the group or family number. So these are the numbers up top of the groups. We can't do it 3 through 12. That doesn't follow that rule. There's much more relationships of why those are various different ones. But if we look over here, the ones digit, 3, 4, 5, 6, 7, 8. Those things, those columns, have the number of valence electrons. So 3, 4, 5, 6, 7, and 8. So everything in there has those numbers of valence electrons. Okay? And that plays a role when we're talking about reactivity. That does not apply to the lanthanide and actinide series. That is just like the what are called transition metals inside. So what we are looking at is what's called the main group elements, the 2 columns on the left, and then the 6 columns on the right. Now, energy levels are also important when we're talking about increasing and decreasing some of the periodic trends we'll talk about. So this is the place where I incorporate them since we're learning about the atom. What isn't labeled on here are the periods. So I'm just going to kind of quickly label them on here. 4, 5, 6, and 7. So the rows or periods are the energy levels that you have here. For example, if we were to look at magnesium, Mg, you know that it would have 12 protons and 12 neutrons. 12 protons and 12 electrons. And as you saw in the activity, it would have a nucleus. And then you would see that it would have 3 rings. And these rings are meant to represent the energy levels. Just as a model, they're not actually formed that way. But the number of electrons would be 2, and then 1, 2, 3, 4, 5, 6, 7, 8, and then it's got 2 more. You're not going to need to memorize that. You're not going to need to go through that. That's not part of what we're learning here in chemistry. That'd be more of a college level or AP Chem stuff. But what you will need to understand is the energy levels, because as we talk about something like magnesium having 3 energy levels, right above it beryllium would only have 2 energy levels. And something like calcium would have 4 energy levels. So when we talk about those energy levels, those are going to be distances from the nucleus, which is going to play a crucial role in determining the properties of things going forward. Be sure to answer the little questions at the end in the Edpuzzle to kind of check your understanding and see if you can apply what we've learned here today. Come in with any of your questions.